Friends and my students and anybody else who is watching. Welcome to today. Today we're talking about geometry, of course, and our lesson is 6.3. We are talking about dilations on a graph. So in 6.1, we talked about dilations, about enlarging a figure or reducing the size of a figure. Today we're going to specifically look at what happens when we do that on a coordinate grid. To do that, we first need to discuss a couple of things. The first of which is the center of dilation. Well, this word we use, all it means is this tells us the point where a dilation starts. I'll go ahead and say we use a capital O for this. Let's also remember scale factor. Scale factor is, oh, there's the bell. Have a good day, everybody. We're done. Kidding, of course. What we are enlarging or reducing by. And we use K to represent our scale factor. I'm going to go ahead and show you the notation for a dilation on a grid, which when you see the notation, you might feel like getting stressed and scared, but stay with me. Once we get to the examples with this, you'll say, aha, that's so easy. So go ahead, write this in your notes, pause if you need to. But here it is. Our notation for a dilation is this. D and then small o comma k of a coordinate xy will be kx and ky. Of course, we can say, if you want to add this, these two things down here, we're just talking about our scale factor and the center of dilation. Let's go ahead and get into an example so you can breathe easy. If I gave you this, and asked you where this point would end up after this dilation, this is what we're doing. See how our, let me change this color. Let's see if there's some good colors. I don't know, this purpley, no, let's do this color. We see this 3, we see this K. All we're doing is we're taking it and we're multiplying it by each of the coordinates. So what's happening is this. It's going to equal 5 times 3 and 3 times 3. We multiply the scale factor by each of those coordinates. So our final answer would be 15.9. That's all we have to do. That's it. Easy peasy. Here's another example. 50.07, we want to dilate the point of -2, 0. Well, we take that 7, we multiply it to each of our coordinate numbers, and when we do that, we will end up with, come on, -2 times 7, 0 times 7. That will just end up being -14, 0. We'll do one more. And this is interesting because now our k, our scale factor, is a fraction. And we want to dilate this point of 9, -6. Oh, excuse me, I wrote the fraction wrong. This should be 1/3. We're still going through the same process. So I'm still taking that k and giving it to each of those coordinate numbers, 9 and -6. When we see this as a fraction, what we're actually going to end up doing is dividing. So this will actually turn into, well, I'll go ahead and write it out. 9 times 1/3, -6 times 1/3. That becomes 9 divided by 3 and -6 divided by 3, which then will equal 3, -2. So even though it's a fraction, we still do the same process. So that's the first thing today, is just getting comfortable with that process of multiplying in. Now I actually want to show you a graph and what this looks like. So I will make, let me actually do this. Let me do a graph like this. 1, 2, 3, 4, 5 should be enough. If I take a segment, so let's say A and B, let's say we start there. Let's say it ends up here at A prime, B prime. First of all, let me ask you, did this get enlarged or reduced? Well, we started with the bigger line segment, ended with a smaller one. Oops, so this is a reduction. Now, I will also ask you, what's the scale factor? Here's how we find the scale factor. Between the pre-image, so the pre-image would be this, and the image, you want to find to those coordinates. So I'll go ahead and pick A. I'll go ahead and pick this point. A is at the coordinate 2, 4. Well, since I picked A, on my image, I'll want to pick A prime. When I look at A prime, where's that coordinate at? Well, it's at 1, 2. All we need to do now is just kind of look, well, if we started here, if we started at 2 and we're ending up at 1, or if we're starting at 4 and we're ending up at 2, what's happening? What are we doing? Do you see how the pattern is divided by 2? We're dividing 2, 4. If you divide both of those numbers, you get 1, 2. The question is, how do we write that pattern? That pattern is our scale factor. But how do we write that as a number? Well, we can still go back to k being our image number over a pre-image number. So we could write it, you can pick the x's or the y's. We could do 4 over 2. Oops, not what I wanted. Well, that just, oh, except I did that wrong. Did you catch my mistake? Ooh, what will I want to do instead? My image number is 2. My pre-image number is 4. So when I simplify this, I get k equals 1/2. You will want to be able, here, let me scoot this down. You will want to be able to find a scale factor by looking at a graph. To do that, once again, all we need to do is find 2 correlating points, so A and A prime, or it would also work if you had looked at B and B prime. Then you can just look for the pattern, or you can use that image over pre-image to simplify and get your answer. That's part 2. We have one more part for today. And it looks like this. I have this figure drawn in, and let's say this is 4, 9, and 7. If I tell you that our scale factor, let me give myself some more space. If I tell you that our scale factor here is 3, I'm going to ask you what OA prime is, what OB prime is, and what A prime B prime is. Well, let's start in. To find OA prime, well, let's just look at our diagram and see where it is. If I start at O and I end at A prime, well, that's that whole side, right? Well, when we, let me use that same thing. When we look, well, we see that OA is 4. Well, if we know that OA is 4, and we know the scale factor, we know how these 2 triangles, the small triangle and the big triangle, we know it's just changing by multiplying by 3. Let's just do that. 4 times 3 gives us 12. So this whole side will end up being 12. Because we know the scale factor, we can just multiply that. We'll do the same thing for OB prime. Well, O and B prime tells us that I'm looking at this full length. I see OB is 7, and I know my scale factor is 3. So when I multiply those, I get 21. finally, we'll look at A prime, B prime. Well, A prime, B prime, that's this length. Well, what side on the smaller triangle corresponds to that A prime, B prime? AB? Yes. So let me use a purple color. We have 9 times our scale factor. 9 because we see it on our figure. Gives us 27. So this length is 27. There you go. That's how, if you know the scale factor, you can figure out the other lengths of a dilation. That's all I have for you for 6.3. We talked about dilations, we talked about it on a graph, and we talked about how you can figure out where points will end up using this notation. Once again, if you have any questions for me, please let me know. Send me an email, talk to me in class. Other than that, have a great day.